Hello my dear students, I will take one more example on a cylindrical shell of 300 mm diameter, 3 meter long and 6 mm thick is subjected to an internal fluid pressure of 2 meganewton per meter square. Calculate the change in the length, diameter and volume of the cylinder under that pressure if the efficiencies of the longitudinal and circumferential joints are 80% and 50% respectively. Take modulus of elasticity is 200 giganewton per meter square and Poisson's ratio is m is equal to 3.5. Okay, so what are the given points here? Thickness of the plate is given 6 mm, so convert into meter, 6 into 10 raised to 3 meter, and length of the cylinder, that is equal to what is the length here? It is 3 meter long and diameter is 300 mm, so divided by 1000 convert into meter, so 0.3 meter, and internal pressure is 2 meganewton per meter square, so mega is 10 raised to 6, so 2 into 10 raised to 6 newton per meter square, and modulus of elasticity is 200 giganewton per meter square, that is 200 into 10 raised to 9 newton per meter square, and Poisson's ratio is equal to 3.5. Okay, here efficiencies of longitudinal and circumferential joints are given. The efficiency of longitudinal joint is 80% and of that circumferential joint is 50%. Okay, now how to calculate the circumferential strain and longitudinal strain? That we know this formula, right? Circumferential strain is given by this EC is equal to sigma C divided by E minus 1 by M into sigma L divided by E. Similarly, for longitudinal strain, that is EL is equal to sigma L divided by E minus sigma C divided by M into E. Okay, now to calculate this circumferential strain and longitudinal strain, first we have to calculate what is circumferential stress and what is longitudinal stress. How you can calculate circumferential stress? Actually, that formula is sigma C is equal to PD divided by 2T. But here efficiency is given, so we have to consider that. For one small observation you have to do here, if it is a circumferential stress, you have to consider efficiency of longitudinal joint. Okay, if it is a longitudinal stress, then you have to consider efficiency of circumference joints. Okay, so now what is the formula to find the circumferential stress? Is equal to PD divided by 2 into T into mu, that is efficiency, longitudinal efficiency, that is equal to 2 into P is given 10 raised to 6, 2 into 10 raised to 6, okay, into 0.3 D divided by 2, thickness is 0.006 into 80% efficiency, that is the longitudinal joints, so is equal to 0.8. So simplify this, you get 62.5 meganewton per meter square or 62.5 into 10 raised to 6 newton per meter square. Then calculate what is longitudinal stress, that is equal to PD divided by 4T into mu of C here. Okay, substitute, you get longitudinal stress is equal to 50 into 10 raised to 6 newton per meter square or 50 meganewton per meter square. Here, as I told, circumferential stress, that is always the longitudinal stress is equal to half of the circumferential stress, but if there is efficiency, that thing will not work out. Okay, if there is efficiency, that is not exactly longitudinal stress is not exactly half of the circumferential stress, that you have to observe or note down. Then what you can calculate? You can calculate circumferential strain, that is nothing but sigma C divided by E minus sigma L divided by M into E. Substitute what is sigma C, that is 62.5 into 10 raised to 6 divided by E minus sigma L is 50 into 10 raised to 6 divided by M is 3.5 into E. So say, can take E outside, that is 200 into 10 raised to 9. Simplify this, you get circumferential strain. Once then you can calculate what is longitudinal strain, that is EL divided by E minus sigma, it is not EL, sigma L divided by E minus sigma C divided by M into E. Okay, so substitute the values, you get what is EL or longitudinal strain. Once if you get that, you can calculate what is change in the diameter, what is the change in the length, and what is the change in the volume. Change in the diameter, we know that is circumferential strain is equal to change in the diameter divided by original diameter. So change in the diameter is equal to EC into longitudinal circumferential strain into D. So if you we want sigma D, that is equal to EC, that is here 0.000241 into D, that is 0.3. Okay, simplify this, you get change in the diameter is equal to 0.0723 mm. Okay, next change in the length you have to calculate. Again, longitudinal strain, that is equal to change in the length divided by original length. We want this delta L, that is equal to EL into L. So substitute EL, that is equal to here 0.000161 into length, original length, that is 3 meters. So substitute, you get delta L is equal to 0.483 millimeters. Then you have to calculate what is the change in the volume. How we can calculate? We know volumetric strain is equal to change in the volume divided by original volume. So change in the volume is equal to volumetric strain into volume. So volumetric strain, how also we know delta V is equal to EL or longitudinal strain plus 2 times of circumferential strain into V. We know EL, that is here this 0.000161, and we know EC also circumferential strain 0.000241 into V. V is pi by 4 into D square into T. Okay, here that is V square into L, not T. So substitute this, you get volume, change in the volume is equal to 136,300 mm cube. In this way you can calculate what is change in the length, diameter and volume, and also you can use direct formula. Which one is easy, that you can consider. Okay, I hope all of you understood. We'll take one more simple example. A boiler shell is to be made of 15 mm thick plate having tensile stress of 120 meganewton per meter square. If the efficiencies of the longitudinal and circumferential joints are 70% and 30% respectively, determine the two calculations you have to do. Maximum permissible diameter of the shell for an internal pressure of 2 meganewton per meter square, and second one is permissible intensity of internal pressure when the shell diameter is 1.5 meter. Here what you have to calculate? You have to calculate in the first case maximum permissible diameter. You have to calculate that pressure is given 2 meganewton per meter square. In the second case, you have to calculate the pressure and diameter is given. How you can do? Take first circumferential stress. What is circumferential stress? Here it is given the tensile stress of 120. Tensile stress, there are two types of tensile stresses: circumferential stresses and longitudinal stresses. So first we'll consider circumferential stress. We know that formula sigma C is equal to PD divided by 2T, but here efficiencies are given, so you have to consider PD divided by 2T into efficiency of longitudinal joints. Okay, now substitute sigma C is equal to, now that is nothing but tensile stress. Here tensile stress are divided into circumferential and longitudinal stress. So first we'll consider circumferential stress. So that is 120 into 10 raised to 6 equal to 2 into P. Now P is given, that is what? meganewton, 2 meganewton. So 2 into 10 raised to 6 into D. D we don't know, we have to calculate, divided by 2 into thickness is given 15, convert into meter, so 10 raised to minus 3 into efficiency, that is for the longitudinal joints it is 70%. So that is 0.7. See here, you have to note down, if it is circumferential stress, you have to consider longitudinal joints, okay, and efficiency of the longitudinal joints. So you get D is equal to 1.26 meter. Then again consider the longitudinal stress as 120 meganewton per meter square. So calculate sigma L is equal to PD divided by 4T into efficiency of circumference joints. Okay, substitute here, you get D is equal to 1.08. So which one you have to consider now, 1.26 or 1.08? So always you have to note down the maximum diameter. To condition, you have to consider the minimum of the diameter. Okay, so that's why I have written here, in order to satisfy both the condition, maximum diameter is equal to 1.08, means that is minimum of the two values you have to consider. That is your maximum diameter. Okay, maximum is not the bigger value, you have to consider minimum of the two values, that is the maximum diameter. Then second case, what you have to do, you have to calculate permissible intensity of internal pressure when the shell diameter is 1.5 meter. Now diameter is given, you have to calculate stress. Use again the same formula, sigma C is equal to PD divided by 2 into T into efficiency. Right, here first consider this circumferential stress is equal to 120 into 10 raised to 6, P we don't know, unknown, into D is 1.5 now, and T is given, everything substitute here, you get P is equal to 1.68 meganewton per meter square. Next calculate in terms of longitudinal stress. What is that? Sigma L is equal to PD divided by 4 into T into efficiency of this circumferential joints. So substitute sigma L is equal to 120 into 10 raised to 6 equal to T into D is given 1.5 into 4 into thickness is 15 into 10 raised to minus 3 and efficiency is 30% circumferential, that is 0.3. Simplify, you get 1.44. So here also the permissible intensity of the pressure, that is minimum of the two value, that is P is equal to 1.44 meganewton per meter square. So like this you can calculate what is the maximum diameter and what is permissible intensity of pressure. Means you have to calculate for both circumferential stress as well as longitudinal stress and compare which is the minimum, that value you have to take. I hope all of you understood. One more example I will give. You have to calculate this, okay? Find this cylindrical shell 3 meter long, which is closed at the ends, has an internal diameter of 1 meter and a wall thickness of 15 mm. Calculate the circumferential and longitudinal stresses induced and also changes in the dimensions of the shell if it is subjected to an internal pressure of 1.5 meganewton per meter square. E is equal to 200 giganewton per meter square and mu or 1 by m is equal to 0.3. So what you have to do, you have to calculate for circumferential and longitudinal stresses and then you have to calculate what is changing the dimensions, means changing the length, changing the diameter and changing the volume. So you do that, we'll discuss in the class. Thank you.